All right, cool. Just as a reminder, so we also already got one feedback on the second aspect. Again, last Friday we talked about the assignments too, right? If you want to do something that's out of the box, think about it and let us know, as soon as possible, so you have maximum amount of time to work on it, but also give us maximum amount of time to think, okay, what do you need for it, so we can actually feed probably some material to you as part of the lectures and so on. Because from now on, the lectures are kind of, we're nearly through with all the mandatory stuff, and then from then on we kind of go a bit, rogue, no, not rogue, but we explore themes that are at the boundaries of graphics that are not super relevant for the course, but that prepare you for, what's up and coming in that field and what you can do beyond. But if it feeds into the assignments, then we obviously want to, should know that in advance to some extent, right? Also bear in mind, there was, just for the ones, you have input into the marking, right? So depending on the choice you have, you can choose whether you want to put more weight on architecture or framework elements, right? Some people are more keen focusing on the C++ part, gameplay usability. I mean, if it's an application, usability, if it's a game, I guess gameplay, whatever, right? So the whole game idea, or aesthetics, if it's a purely graphical application. So that's something you should bear in mind when you start conceptualizing your approach. Bear in mind that there's some minimal features you need to have as part of that, which include lighting, texture loading, and some sort of mouse keyboard interaction, but probably more. That probably doesn't suffice to warrant 30% of your marks, so you need to come up with a bit more, but that's the essence. Cool. So if you have something in mind, it's later on just come up and pitch the idea. So either to those guys or ideally to us all three, so we can think about it and see if your problem points into the right direction for an assignment. So the earlier the better. Feel free to brainstorm, and just throw up or come up with some ideas. Okay, so much about this. But we talked about this on Friday, so there shouldn't be any surprises. Any questions regarding this for the ones that actually read the instructions again? Do you find typos? No? Okay, apparently not. Right, lucky me. So, on Friday, what did we do on Friday? I don't remember. Do you? Okay, that's exciting.
We recapped.
Was I here on Friday?
We finished off objects, I think.
Yes.
And then we started talking about something.
It's not on here, no? Actually on there. Anyway, no, we started talking about. Come on. Yes.
Scenegraphs.
Yes, Scenegraphs.
Yes.
Cool. What were Scenegraphs about? Why do we need them?
You don't have a tree, and then you could say that if the arm is part of the body, then if the body rotates, then the arm should rotate as well.
That's right. Right. So the idea of dealing with complexity. Right, so having individual models is cool and it's fun, right? You have a car and wheels and all that kind of jazz. But if you need to have that car run through a scene, right? That's a road or a terrain or so on. Then you actually need to relate those two ones as well. And let's put another element to it. Let's say the viewer, for surprise, surprise, who actually rotates the scene or does some sort of transformation. And everything in the scene needs to transform as well. So you don't want to apply it individually to all the models, right? That they are part of your scene. And that's where the scene graph comes in, that everything is kind of related by definition. So you basically just modify the scene, and all the transformations that are applied to the scene are applied to the children of that scene graph, and therefore it's a consistent perception from a user perspective. And which tool did I allude to? I must have been a Friday, or I must have been talking way too fast on Friday, or something. Or is it just me being delusional? That's possible. No? Which tool did we use?
Open Scenegraph.
Brilliant. Brilliant. Okay. Open Scenegraphs. Right. So, did anyone have a look at it in the meantime? Good. Because it's really nightmare. So, I mean, yeah. I mean, running this tool it's unbelievable. I'm not sure when the latest update is quite some while back, but apart from the fact that it has been around for some time and not really updated, or only incrementally updated, the worst bit is the documentation, because there's hardly any. I mean, they have a basic get started section which is full of errors, no official documentation, some Doxygen overview of the class structures and so on, but it's really limited in terms of providing you with thorough introductions. So if you really wanted to use that tool, you probably need to end up either buying a book to do it or follow some other tutorials. But I want to share some intuition as to what the tool does. And I gave up on the idea of running it on my machine because that doesn't work. I tried like the whole week, and every time I want to use the second screen, then something goes wrong because my machine is, I don't know, from the last decade, I guess. So, but that's why we thought we make the assignment or the tutorial, if you want to spare the time, to actually make you run that tool, because there are actually good examples in there that just give you an intuition by code inspection as to how you could construct a scene. Yeah, but just before we do that, I'll just go over some conceptual elements of Open Scenegraph that make it easier for you to read to read the code and understand what's going on behind the scenes. Let's see. So fundamentally, Open Scenegraph comes with a set of tools, right? We have the core utility that's available and allows you to specify the actual graph and so on for different types of elements that's focused, for example, on text or simulation. Or this one is actually referring to textures here. And simulation, so you have animation functionalities and so on that are provided out of the box as well. But then there's the whole utilities world, which is about traversing the graph and applying transformations to it and further enhancement. So it's a strong plug-in based architecture that's defined for OSG. And then the actual loading of models is a separate module, and plugins generally refer to supported data types, right? So like OBJ for as a base model, the native OSG and OSGT format, yes, and 3DS and so on. So you can actually load a large number of different object formats in order to render those, integrate those into your scene graph. And we briefly or tried to look at something that's related to that. But what I wanted to highlight, probably to make it clearer, which didn't quite work out on Friday, was how the structure internally looks. So the scene graph tree fundamentally relies on the idea that you have some sort of node as a base class for everything, because fundamentally it's a directed acyclic graph, right? So we can have links between individual components, but in Open Scenegraph, a specialization of that node would be a group, which has some transformation matrix. So it's a 4x4 matrix that any transformation is applied to, and then it is basically pushed through the entire tree or the entire branch, if you like, and applied to all the children, right? So the transformation, let's say if you rotate a particular object in your scene, is applied to all the children of that particular group. Then there's switch functionality, level of detail, light sources that can be specified on group level, so one or more groups. Jonas has an addition to make.
Why is the transformed 4x4 matrix and not 3x3?
We get to that again later, right?
Okay.
But yes, it's the when we talked earlier about matrix transformations, we always had the differentiation between a transformation of directions and points, and that's reflected in this matrix.
It's just the mapping of.
Yes, that's right. So that's the idea. Mm-hmm. So, and then point is, as soon as you modify if you modify the matrix on a given node level, right? So it's multiplied with the children as well. So you see the modification. Another form is the geode, which is pretty much like there's a leaf node in the entire structure, in the entire tree, basically, and it's it's geometric node. Basically, it's any sort of thing that you draw an object that sits at the end of that entire tree. And that obviously can consist of further, geometric primitives and so on, but it's kind of self-contained, an object that sits at the bottom. A special form here is that you can initialize those drawables, right? That's what I'm looking for. The drawable elements, geometric primitives, can be initialized as being buildable style drawables. That means they're always oriented towards the viewer. So they will ensure, irrespective of the rest of the graph and the orientation, that they always point towards the viewer. For example, if you have text over a individual NPC and so on, it will always be directed towards the camera, yeah, independent of the direction of the NPC, for example. Billboard concept, in case you come across that.
Often used on grass and bushes and trees.
Right. And so, right, the drawable is kind of the core concept if you think about objects, because that's where you basically load your entire object, including the geometry, including vertices, normals, color, texture coordinates, and all that kind of jazz, potentially text, and yeah, drawing of individual pixels if you want, which is kind of a special form. And as on the higher level, we have a state set which encapsulates all the boilerplate stuff for OpenGL that you initialize at the very beginning. And you have separate elements that can be textures that can be linked to the OpenGL texture functionality. And roughly, in a nutshell, the structure is generally like this. So you have some sort of group and associated some sort some transformation matrix, and then which has those geometric nodes as children, right? So and the geometric node is made up of out of one or more of those drawables, which are the actual drawn component that are drawn to the screen. And yeah, but from a code perspective, it roughly would be like this, right? So you have some sort of group. You specified some sort of geometry for the leaf node, basically, and basically just attach that geometry to the leaf node, and then link that leaf node. Leaf node. There you go. That's better, isn't it? To the actual root, and then you display the whole thing, right? So that's a rough idea. That's how it works. That is a bit pseudocode here, but the idea should be somewhat clear. Obviously, you can have one or more children, so you can develop your own graph structure using that mechanism. So it really depends on what you want to use Scenegraph for, because it's not only about hierarchy in the Scenegraph itself, but it comes up with a lot of different additional features that have been plugged in, I guess, over time, which is things like animations, but including the drawing of own graphic, on geometric primitives that it supports as well. So there's a lot of plugins for that, but some of them are those ones here that are generally available: the box, sphere, cone, cylinder, and capsule, I think it's called, which are available out of the box. But there are a large number of further kits, referred to as node kits, that allow you to introduce further features. So if you want to do, for example, special effects, particle rendering, the visual simulation bit, shadow, terrain rendering, text rendering, animations, and volume rendering as well, which is available as a plugin for OpenScenegraph. The question is, there, you as a graphics programmer, I say, designer, programmer, whatever. So I'll say programmer right now. You need to decide how far you want to buy into that kind of framework, right? Because once you bought in, you're kind of tied, or once you want to use any of those this functionality, you're kind of bought into the framework, and it will be pretty hard to generalize your code again to move to a different solution. So OpenScenegraph is only one of them. There are so many others out there, many built into their particular game engines or platforms. So it's really more like the principle that counts here, as opposed to the actual use. So that is something I want to remark at this stage.
Is there no unique, sort of standardized way to do this? Standardized system?
And the closest to one thing that would be a standard is, which one? We talked about it last session as well, briefly. What's an open standard? One of them. Scenegraph formats. It's a web format.
Oh, the
exactly that one.
The replacement for
yep,
virtual.
Exactly.
virtual
How was that
reality.
called? So much about a successful 3D format that no one remembers it. But I wouldn't either. So.
Only remember
X3D.
it was the replacement for.
It was a replacement for something.
X3D?
Yes,
Yeah.
X3D, right? So that's basically an XML format that has a scene graph built in as well, and that's probably closest to something that's fully like standardized because it's an ISO standard. This is here the open scene graph is a community standard at best, so it's kind of a bit of a different objectives here, different object. Yeah, I should have done that. Yes, I can't resist every time I try it again. But this is kind of a nice demo that allows you. Yeah. Sorry, stream. Anyway, so that's the right side of the picture that I see on my screen. But it's basically the idea that you have a sun and then some planets circulating around it. Not just some planets, the planets actually. The idea is here that it's a good way of modeling this whole scene graph and the velocity and angular velocity and the distance from the sun and so on. So this is one of those examples that you can explore explicitly in an open scene graph. I talked about the robot as well, but again, you only see like hardly anything of it. So I would encourage you to play around with yourself to see those dependencies. But I just come back up with the code example for that one. So here we have this exact pattern. So we're creating a group. We have the transformation matrix that's attached to that particular group. Then we build using some sort of custom function the joints. So it basically builds the individual joints. And in this case, it's a geometric node that relies on a cylinder. So you use the cylinder shape that's built into open scene graph and attaches a z-axis for transformation and then returns this whole thing. And the idea is there that the transformation matrix that's returned by this for build join 1 is basically the basis then for linking further joints to that particular geometric node, right? So the second joint is attached to joint 1. The third joint is attached to the joint 3 is attached to tube 2. Tube 2 is attached to joint 2. So if I show you the model of the robot again, you will see that the structure comes about by just looking at the relationships. And the idea is that it's super easy to redefine those relationships. Hang on. Without actually touching any of the geometric nodes shapes or properties. You just reattach them to a different part of the graph. And where is that coming up? Just see if I can bring it up again. So. All right, there he is. No, it's not. So anyway, so the idea is again, you have different components, and you can attach them with different axes and play around with this, the joints and different forms of rotations that are supported, and in different angles. Again, you need to do it on your own because I can only see half the screen. If I bring it completely to the second screen, then everything fails and the stream will blank out. So. It's a bit challenging. So I encourage you to play around with that yourself. Some mini lab instructions regarding that are on the wiki. Is there anything else I wanted to lose on Open Scene Graph? No. Perhaps one comment. If you really feel inclined to build your own one, because Open Scene Graph, again, it's not fully standardized. It's the de facto kind of framework that's used quite popularly. So what would you need to do to build your own scene graph or structure, which you could kind of do? You need to have your model loader, which you can use something you know already. You need to be able to represent some tree hierarchy. and deal with node addition and deletion, so adding and removing of children, and the ability to traverse this entire tree, so you can actually apply the matrix transformation to selected branches of that particular tree. So it's one possible way of doing it, but I think it's probably, so meaning if you have a lightweight solution, for example, for assignment 2, and you have these dependencies, you could consider building that yourself, right? It's just for your purposes. But if you want to go heavyweight, then Open Scenegraph is an option, but it's kind of involved, and you're really buying into the framework, so your entire application depends on that framework quite intimately. So it's not something you can attach briefly and then use where needed. It's kind of something you need to deal with on a detailed level. Coming back to my ambition to show you so it's somewhat barely legible. So a few things. If you want to use Open Scenegraphs, so you download it, ideally based the sources, which are on GitHub. I think they moved some time ago. That's good. The important thing, you download it and you build it using CMake. The important thing is to switch the activate the build examples flag. If you don't do that, it doesn't build with the examples, meaning you can't use the examples on your framework itself. Yeah. So that's basically it. So if you use CMake GUI, look for that particular switch and set it to true. It's not set by default. Yes, and then just follow the instructions here. Basically, you need to, in Windows, need to set up your, you also need to download additional graphics resources, which are used for the examples, like the resources for rendering, for the textures, for example, for selected examples. And add this to your path variable as described here. Note in the documentation there's a typo. So that's the fixed version in case you plan to do that. And I encourage you to play around with the models OSG planets. We just saw that one. It's quite nice because then you see the how to deal with hierarchical structure and rotation. The robot, which is pretty cool for playing around with different joints, reattaching things, and see what it does. So it's quite kind of intuitive dealing with this. And if you want to use your GPU a bit, try OSG Forest. That actually tries to render a forest on a plane with, I think by default, 10,000 trees. So it's quite involved. I will abstain from doing that on this machine. Yeah, so just feel free to play around with some ideas of what you could do, but it's just to develop an intuition of how those frameworks basically work. Yeah? And then you can decide, okay, do you want to go down that track and actually use them for your assignment? That's up to you. But they're kind of versatile. You can use them both for any sort of graphic application like a viewer, but also for games and so on. So it's quite flexible. If you download the examples, you find them as OSG files. So the entire graph structure. And you can load this using the tool OSG Viewer D, which is provided out of the box as well. So that's quite handy if you want to inspect some of the models that are available. Some examples don't work. So yeah, I don't know. I tried a lot of them because there's quite a nice selection of them. But again, I think it boils down to this ill-fated maintenance situation that a lot of cases the textures are missing for certain geometric for geonodes and so on, for drawables rather, which doesn't really matter. They still draw, but they don't have textures. But so there is a bit of dodginess going on there, which you could obviously refine, but I probably wouldn't waste time on that. But just to get the intuition, I think everything is so far okay. Yes, Visual Studio people. I would encourage you to run the examples from the command line. So if you run Visual Studio, because you get a lot more feedback in terms of errors. Because otherwise in Visual Studio, just show error code exit 1 and that's it. But you actually need to see the console output to see why things don't happen. Obviously, people that run from the console don't have that issue, meaning Linux and Mac users. So that should be fine. The official documentation is really average, so look for third-party things. There are books out there, and there's actually one tutorial from Lulea Technical Hochschule that's maybe worthwhile looking at just to get the intuitions. But it's written for Java though, so it's not one-to-one, but it gives you a lot of the conceptual intuitions that you need to deal with that tool. Thoughts, questions? Yep.
You build it?
Yep.
With CMake?
Yep.
You just clone the
Yes, that's right. That's the way I approached it. I think it's a recommended way as well. You just go use the stable release, clone that, and then build it with CMake. Yeah, CMake. Any CMake news you guys want to share?
Well, we got CMake in Visual Studio.
Everyone, yeah?
Built it.
They're really excited. Everyone is excited in this room. I sense that, right? There's a real vibration, CMake being the core of this entire graphics course. So yes, so native support for CMake in Visual Studio, right? So that's pretty cool. So you actually can use the CMake list directly and don't need to use any third-party tool anymore to deal with this. Shortcomings?
I had some issues with the resources for the executable. I had to put them into the bin folder for the executable to be able to
That's
access
the
it.
same issue that you had.
Yep. Okay.
You had to copy
Yeah.
the shader.
Yeah, I stopped that one.
Yeah.
Except for Windows, I have to copy the glue PLL.
Yeah.
Yeah.
Yes. You
That's one thing I had to do
Cool.
and the shaders.
Yeah.
Otherwise, it was
Dreadful.
really
Cool. So it's probably good for anyone who uses Visual Studio just to try it out to get a feel. What I really liked when I saw it is really that the fact you don't need to deal with this solution complexity, right? So you don't have the unnecessary adding of files that are obviously apparently available in the file system, but you just have the entire file system structure shown, and can operate based on that one, like you can do in other good IDEs. But Visual Studio goes its own ways there. But if you use CMake, you circumvent this, so you can use it. So if you feel keen to explore that, go for it. There was another limitation, IntelliSense, right? You mentioned.
I had some issues with the IntelliSense giving errors, which weren't really errors, but that was as simple as just going into the options and disabling it for unused systems.
Unused. Can you still navigate from, for example, from a method? I don't know, from a method call to its definition? You still retain that functionality? Because this navigation, that still works. So that's quite powerful. So as long as that works, I think then people can easily, retrace the structure. Okay, well that's the other thing. So if you want to use CMake natively, that would work as well. But so CMake here actually kind of works. So good luck with that. Try it out. Again, build the examples with it, and you need to download and link the data manually though. That's the thing that's not done out of the box. Cool. We leave you to that. Is there any group that has other ambitions with respect to their assignment 2? Yep, cool. You guys have. Anyone else? Pac-Man it is, largely. That's fine. I mean, that will be ambitious enough. I'm just inquiring. Okay, cool. Yes, sweet. Well, happy hacking for now. We'll probably chat and see what you guys come up with, so we can plan for or against that.